So by utilizing methods like the creation of regional nutrient loops, I'll explain. The circular agricultural idea may help repair and improve the condition of the soil. Rethinking our agricultural value chains may help reduce food loss and waste. The adoption of sustainable food production systems and resilient agriculture is a key component of SDG 2. So, yeah, which aims to boost productivity and production as well as create resilient ecosystems that can cope with climate change and major catastrophes. So let me explain regional nutrient loops. So what happens, like we saw in the circularity, these are kind of things, this is how it goes. So at the end of life stage, when certain thing comes to like like a salvaging, okay, so you can break it down into like a components. These components again are fed as like a source, as a resource to a fresh like a new cycle of like a manufacturing, okay, that you can call it as a like a nutrient, right? So this becomes as like a nutrient to this one, the new cycle, right? So regional nutrient means something which happens locally at some place, for example, okay, that is unique to that place itself. Then again it varies to the other place and so on. So that becomes like a regional nutrient loop. So every place might have its own like characteristic and features, like what all it can add, right? So that is the thing. And for food security systems, that SDG 2, okay, what is needed, it is given here in this paragraph. Production systems, adoption of sustainable food production systems, because this we have, but we want like a sustainable food production, okay. So resilient agriculture, because agriculture, if you see, is a traditional like a sector where our like India is known for its agriculture and all that, and huge like a number of like a farmers, okay, and this has been prosperous from a long time, and because of like this agriculture like sectors like a very great contribution, right? So resilience, because still if you see the conventional agriculture follows the conventional like a rain patterns, right, and seeds and all of those things. So how those like can be improved and be given like a adaptive capacity, or like this bouncing back capacity, that resilience, okay, so that it doesn't get like impacted in case of any catastrophes and disasters, or maybe like a droughts, floods and all of that kind of things, okay, because ultimately it hits the like a farmer, right, the lowest unit in this whole like a chain, the various like levels, okay, this comes right over here, okay. So if this gets impacted, all of this get impacted, right? So to safeguard this, to make this food secure, right, to guarantee this thing, we need to guarantee at this stage also, right? So it's the same thing, like this guarantee getting translated to the last level. The circular economy's nucleus might be biomass. It is categorized as a renewable resource with a wide range of uses and ability to absorb CO2 from the atmosphere. One of the examples, okay, of like a biomass. For example, biomass may be used as a source of food, animal feed, material, transportation fuel, and energy. So biomass these days, like if you see, has become a very important, like ingredient, of even power generation also. That's why you are seeing, like energy over here. Like all of this agricultural produce, once it is kind of harvested and the crop is kind of like taken care of, okay, the residue part which remains in the field, okay, that contributes to this like a biomass, right? So how that can also be used, because typically it goes like a waste, like it is thrown, right, it kind of like a rots here and there, okay, and sometimes it goes in the landfill, like sometimes it is thrown, sometimes it is fed as like animal feed and things like that. So those are the things we are seeing over here: food, animal food, material, transportation fuel, and even energy, okay. So is another like a new, not so new, but yes, developing applications of it, or bringing efficiency into this whole like a biomass thing, is a new phenomenon which is happening on a very fast. It refers to a variety of agricultural commodities, timber, grasses, water-grown plants like weeds and algae, as well as residual streams that occur along the supply chain from harvest to consumption and ultimate processing rather than a single resource. Biomass is also regarded as a products made from animal byproducts. Okay, so that also is used. Food is an essential requirement for human life. The food system we have now is not yet sustainable. How we can continue to feed the expanding global population as well as the challenges of quality and safe food, healthy eating habits and sustainable circular production methods and crucial concerns for our food supply. Two significant obstacles are the provisions of protein and food waste. So like agriculture is there, coming down, from generations and hundreds and thousands of years. Food systems also, if you see, we have, this supply and supply, demand supply, like a chain, but we know like a huge percentage of it goes into the, like a waste. It gets simply just gets, like wasted, okay, which is not a good thing. So overall, like how, and in the previous, lectures we have seen how some kids are like overfed, they are overweight, and some kids are facing stunting and I don't know, like a less weight and less like a body height and less nutrition, not so proper growth of the body and all of those things. So these are actually like a gaps which needs to be like a filled. Okay, so that thing. So how this can be done, that's the actually a challenge for the system. The amount of food that is wasted globally ranges from food that is not consumed to food that is waste, during the harvest. So harvest time, in the harvest time also, actually it starts kind of like a getting wasted. So if it is a paddy or like a wheat field, you may have seen. Okay, so while harvesting, taking these like seeds, like this part. Okay, some of it actually like a falls, and if you calculate, that also comes to like a big percentage. I don't like it varies place to place, but it comes overall in a big percentage, right? So more than half of the all agricultural land is used for the production of animal feed. From manufacturing to consumption, the entire chain seriously disrupts the environment. So here you can see like this four like aspects in agriculture like a sector. So we have this at the top: crops. Only 30% of crops are suitable for human consumption. We can use the other parts, and residual flows from agriculture and the food industry to produce animal feed. Okay, so how efficiently it can be used, because overall if you see production, there are like these seeds which are the most like a usual thing, and then there are stem and leaves and all of that. So it is assuming like all of that, like all of these parts also can be used for like a variety of purposes, right? The cattle and sheep can consume grass and herbs in pastures that are unsuitable for growing food, such as the peat grasslands in the Netherlands. Okay, so maybe you can search it separately. It's an interesting, devoted, like a land, okay, where cattle actually feed, freely and roam, like on this thing. Manure is also a valuable source of organic material that replenishes the soil and completes the circular, agro-food systems. So soil in itself is not good enough, to support agriculture. Soil is the, like one of the strong mediums. With the help of nutrients, moisture, and manure, so manure is that like a it becomes like a manure once it gets inundated with like right amount of like other elements also, such as I mentioned, like water, that moisture, and like a manure, nutrients and many other things, right? Then it becomes like a full like a manure which supports, which is able to give like a nutrition to plants, right? Otherwise simple like a soil, maybe a dead soil, if there is no organic like compounds, no like a moisture, no water, right? Then it will be just like a piece of rock or maybe a sand or something, okay, which cannot be used like directly, right? So only this you may be aware on like this entire planet, this we have like this crust, and in that also just first like a few feet like a depth, 2 to 3 feet like a depth of like this soil actually carries the most like nutrients and like a manure and moisture and all of that, right? right, which is right for the like agricultural purpose. Okay, if you dig deeper, it will contain maybe other things also, maybe pieces of stone, bricks, and like other things, not so suitable for like direct agricultural uses. You have to turn like that soil into a proper fertile soil, suitable for like agriculture. Land. Many from animals contribute to the fertile healthy soil and improves crop yield. So of course, again, these plants, once they are discarded, okay, some amount of it, this actually gets rots and decomposes, and then it kind of discharges like a nutrients, which help further like a boosting like a nutritional value of like a this soil, which again helps like a crops. So you see this whole thing, the kind of like a cyclic like a relation here also. One leads to like another and helps another, and sometimes complements also. Yeah, so we were talking about wastage in the food system. So now with this, you can see where is that whole like a waste happening. So it's a typical like this thing from Canada, right? So 2 of every 5 of all food produced in Canada is wasted. So it's like like a 40%. I don't know. It's a mind-boggling like a figure, like how like is it possible to waste like a 40% of total produced food. It's really like a disturbing. So in the farms directly at the rate of 10%, okay, and then it goes to the manufacturing processes here by 20%, then transportation and distribution like a 4%, then in retail places also around 9%, food services may around 8%, and households like like at the consumer level, you and me, when we eat, okay, we end up sometimes wasting 48%. Okay, that's the study from Canada. Okay, so here we have this hierarchy. Okay, so where is it possible for you to like bring the most impact, most like a favorable control or impact? Okay, so by prevention, which is there at the top, waste of raw materials, ingredients, and product arising is reduced, measured in overall reduction in waste. Optimization, redistribution of people sent to animal feeds. For recycling, waste sent to anaerobic digestion or waste composed, that is aerobic. Recovery, incineration of waste with energy recovery, like if you kind of make it as a feed for power generation like a plant. So some of the power generation, new power generation plants, they run on the waste also by burning waste. Disposal, waste incinerated without energy recovery, waste sent to landfills, waste ingredient product going to sewer and other like places. So this is completely like undesirable kind of situation. So here you can see this is the stage where prevention is possible, most preferred, most favorable, then reduction, and then this is the not so favorable zone. On the same line, like the value, how much is the value added into this whole hierarchy? Okay, so here you see it gets like increased, like increased value. Okay, and volume. So this side it is like a more volume, but this side it has like a more value. Okay, so health and lifestyle, pharmacy, fine chemicals, nutrition, animal feed, nutrition. At the bottom side we have fuel, electricity, warmth, energy. Then the middle, chemistry and materials, high quality materials, etc. etc. Yeah, so related to SDG 6, we'll see half of the world population already faces acute water shortage that we know. In India we do not have like a potable like a water supply in our taps. Okay, we need to use like separate maybe filtering like a units for that purpose at least once a year as a result of the demand for water outpacing population growth. Although having access to essential amenities like water, sanitation and hygiene is a human right, billions of people still struggle every day to get such things. 3 out of 10 persons do not have access to services that provide clean drinking water. 3 out of 10. Around 3 billion people do not have access to basic sanitary facilities like latrines and toilets. More than 80% of wastewater generated by human activity is dumped untreated into rivers or the oceans, which cause pollutions. So, you see this, more than 80%. you know, of like a wastewater, which comes from like a toilets, it goes directly to the rivers or oceans or other water bodies, which in turn definitely like causes a lot of issues in the ecosystem. The utility of circular economy methods we'll see here. So here water based like one circular economy's model is drawn. Okay, like how can you go for optimizing or maximizing the like efficiency of water in the consumption like cycles, and how this can be like saved from getting wasted. So here water efficient technologies, closed loop system, reduction of losses and leakage, water absorption rate does not exceed the renewal rate, So here recovery of value constituents from processed water, industrial symbiosis, it goes here. Site specific decentralized removal of hazardous substances. Okay, so that it gets treated and there is no toxic like a waste going into the system or in the water bodies, in the soil. Recovery of nutrients and energy at wastewater treatment plant. Reuse of treated wastewater or its introduction into the environment. So from here again it is kind of we call it as safe enough, okay, to go back to the like a system. So here we see like agriculture system, right? So we have cattle, we have like these trees and plants, right? Then from here recycling of water and nutrients and water efficient irrigation system. Recycling of water, management of water balance, recovery of substances. Okay, and from here if you see like a deep intact, so this percolation allows water to go in, seep in, and they actually get deposited over a long period of time in small like aquifers, sometimes they run in several kilometers. Okay, and from here we actually take like our water supplies, like necessities. So, a circular economy can help achieve universal and equitable access to safe and affordable drinking water by the development of technologies and systems like small scale water purification technologies. One of those technologies is desalination. Like many places, they have hard water, or like even salt water, like our oceans, they are all like salt water. This thing. So even there is so much of water, we cannot use it for our regular consumption in its as it is formed, right? So there is this technology desalination which takes out those hard salts and makes water like usable. But this currently it costs like a lot. So not everybody will be able to, or not every country also is able to like afford and distribute in places. So wastewater treatment, reducing wastewater discharge into drinking water sources. The International Water Association provides a framework in the report Water Utility Pathways in the Circular Economy to assist in the identification of opportunities and the means to take full advantage of these opportunities within three interrelated pathways: the water pathway, the material pathway, and the energy pathway. Related to SDG 7, all sectors from commerce, healthcare and education to agriculture, infrastructure, communications and high technology benefit from a well-established energy system. Of course, because energy, the demand for energy is from, like all the sectors, there is no one or no entity which can say they don't need, any sort of energy, because they're conducting, for their conducting, like a works and, like a machines and even like a other type of, requirements, energy is an essential requirement, right? So 9 out of 10 people worldwide have access to electricity currently, but 87% of the 840 million people without electricity live in rural areas. So rural areas, if you see, are the majorly impacted ones. On average, 2.3% less energy was needed to create $1 of economic output each year. So there is like a saving, 2.3%. Less energy was needed. Okay, so that much was saved for every $1 worth of economic output. 3 billion people lack clean cooking fuels and technology. So they do not have perhaps like LPG, butane like a supplies. Okay, we call it typically like clean like energy clean cooking, like energy sources. Okay, so out of 8, 3 billion people have no access to, like a such clean cooking systems. Energy efficiency is continuing to advance. Renewable energy is making significant progress, and access to power in less developed nations is starting to pick up speed. However, more concentrated efforts are required to increase 3 billion people's access to clean and secure cooking fuels and technology. Today, about 90% of people have access to power, but more work has to be done to reach the remaining 1%. An estimated 573 million people in sub-Saharan Africa still don't have access to power. Without power, individuals cannot operate profitable businesses. Clinics cannot keep child immunizations. Many kids cannot do their coursework at midnight. And women and girls must spend hours gathering water. So if you see, with the lack of power, how it impacts, like people from the rural areas, right? So there is a huge number of like people who are still living without power. So this is one important point mentioned here. For immunization schemes, one needs to carry vaccines to the faraway places, and since there are no cold storage like a systems properly in those places, there is no continuous like a supply of electricity, right? So this is prone to getting damaged or get spoiled, right? So just imagine, like so much of effort actually goes into producing like such thing, and if it gets just simply wasted because we do not have storage systems, it's really unfortunate, right? So this is one of the examples where like in electricity, this energy is an essential component in today's time, because even if you are not using it directly, but you are using it definitely indirectly in many forms, even if you come from far away remote like places also. In relation to SDG 8, economic growth that is sustained and inclusive can advance society, produce good employment for everybody, and raise standards of life. Although labor productivity and real GDP per person have improved globally, 731 million people still live in poverty, defined by living on less than $1.9 per day. So the real GDP grew by 4.8% annually. Median hourly pay for men is 12% higher than that of women. Okay, so still there is like a disparity. Global unemployment rate 5%. 1/5 of young people are not in education, employment, training. In reality, 8% of working people and their families lived in extreme poverty globally in 2018. Over 700 million working women and men do not make enough money to help themselves or families out of poverty. Effective globalization and eradication of poverty depend on productive employment and decent labor, which are essential components. The economy of today is wasteful. When resources reach the end of their useful life, the majority are permanently lost in landfills. In a circular economy, these resources are kept in use through recycling, remanufacturing, repair, refurbishing, redesigning, etc. These are the better options over recovery and disposal. Of course, because recovery and disposal are the last resort, the creation of job is a crucial component of proceeding down this route. A circular economy really generates more jobs than a linear economy when compared to primary output and the extension practices of disposal in the linear economy. These employment are also relevant and local. Designing products to endure longer can result in higher reuse. Improving repairability can help the expanding remanufacturing sector and making it simple to recover components when a product is finally discarded. Examples of circular business models. Service models, which can include peer-to-peer sharing, leasing and product maintenance, and take-back programs, also have a lot of promise. So take-back programs, I think you can underline over here, product maintenance and take-back programs. So take back programs are like sometimes you may have seen while buying a phone, companies give like a sum, like a money in exchange of your old phone. Around 3.4 million people are currently employed in circular economy industry. According to projected development goals, this number will rise by 1.2 million jobs. Related to SDG 12, the global material footprint is rapidly growing, outpacing population and economic growth. Developed countries use 1/5 of natural resources.